Now we're going to look at forming compounds using polyatomic ions. So I have provided you with a list of polyatomic ions. So that essentially is a group of charged atoms. Now these have all sorts of different names. Most of them have negative charges, but we do have ions like NH4, which is a positive one. Or we have SO4, which is -2, SO3, that's -2. So this entire group of atoms is all together. Maybe we have a PO4, which is a phosphate ion, which is a -3, or a phosphite ion, which is also a -3. Now these become really tricky when you're naming or when you're trying to identify different compounds because their letters are so similar. But the important thing to note when we're naming polyatomics is they all end in -ate or -ite when they involve oxygens. And I will allow you to use your ion table, which tells you the names of all these crazy polyatomic ions. But when we're forming a compound, where does this all come into play? So if I'm looking at, say, sodium, which has a +1 charge, combining with sulfate, which has a -2 charge, okay? So once again, I'm going to take my big charges, and we do the same process. I'm going to bring this 2 down, I'm going to bring this +1 down, and when you combine these two things, I just end up with Na2, and there's going to be 1 SO4. So I don't need to do anything different. I don't need to put a 1, no need to mess it up. We're just going to leave it all together. These get a little tricky when we need multiples of the polyatomic ion. So let's try another example. If I wanted to put together calcium, which is a +2, with phosphate, which has a -3 charge, okay? So I'm going to bring down my 3, and this becomes Ca3, and then I bring down my 2. Now what this tells me, okay, is I have 2 of this PO4 group. So what I want to do is I want to put the PO4 in parentheses, and I put the 2 on the outside. So this tells me I have 2 of the phosphate group. A lot of times people don't want to write the parentheses, and if we were to just put a 2 here, okay, if I had Ca3 PO42, what that ends up looking like is that I have 3 calciums, 1 phosphorus, and 42 oxygens, okay? But really, I have 3 calciums and 2 phosphorus and 8 oxygens. I have 2 of this group. I don't have 42 oxygens, so we don't want to make that mistake. That's not what we want to write. Now, what if we use this compound where I have aluminum, which is +3, and hydroxide, which is minus. This is the one. Don't be that person. There's so many people that always forget that hydroxide is a polyatomic ion. Just because it doesn't look like a 42 doesn't mean we don't need parentheses. So when I crisscross these numbers down, I'm going to have 1 aluminum, Al1, I don't have to write it, and I have 3 of the hydroxide group. Now, this works the same exact way as if my polyatomic is my cation, okay? So in the case of ammonium, where I have NH4+, you know what, let's just combine it with a polyatomic for fun, with SO3 -2. I can crisscross my charges, but I also want you to think, if NH4 has a +1 charge and SO3 has a -2 charge, how many NH4s would I need to balance out the -2 charge on my sulfite? 2. So this just becomes ammonium sulfite. Now, I have 2 of this group. I only need 1 of this group. Now, some people find it really helpful to put this in parentheses no matter what, so that you know that group is staying together. Although this is not technically correct, I am not going to mark it wrong if you need to do this to help you remember that this is one group. Now, when we name these, the same thing happens where I have sodium. I leave the metal alone. And we're going to look at our ion tables to identify what this is. Now, I don't want you to do anything crazy. I don't want you to write sulfur oxide or sulfoxide or sulfur tetraoxide. You'll notice that none of these compounds have weird prefixes. If this is all together in one group as an ion, we're going to name it all together. So SO4 -2 is a sulfate. PO4 with a -3 charge. This right here is going to be calcium. I'm just going to squeeze it in. Phosphate. AlOH3, this is aluminum hydroxide. And my NH4, I told you, is ammonium sulfite, is SO3. Now be careful, really make sure, because 3 and 4 is a slight difference. We're only off by 1 oxygen, but those are very, very different polyatomic ions, and one ends in 8 and one ends in 8. So make sure you're referencing your table when you're naming polyatomic ions.